Can everyone see my slides?
Yes.
Wonderful. Thank you so much, Bella, for the opportunity to speak at this wonderful event. Congratulations to all the students for their completion. And today I'm going to tell you about a project I'm currently an observer on. I'm the part of the ELSI panel, the Ethical, Social and Legal Implications of DARPA's Adapter program. So before I begin, just quickly, I'm not an employee of the Department of Defense or the US government, and I don't work for DARPA, and the views I'm sharing today are not necessarily the views of DARPA, DOT, or the US government. So I just put that as a disclaimer. A lot of you will be working at the interface of software and hardware. That's a given software development. But there's also an additional bubble I want you to think about, the human. We often talk about human-centered design, but we often forget about the human. You can look at any large-scale system around the world today, and you'll probably be demystifying the fact that humans are not really that important in the process, according to some people, or the way they actually do development. But as you know, in development, the human is the first person, or object, or subject, or thing, or entity, more precisely, that you go to. And HSI, Human Systems Integration, is constantly in that evolution from human systems engineering. NASA has adopted and created that term, human systems engineering, to mean the intersection of software, humans, and hardware. Think of systems and how they're arranged. So the project I'm working on as an observer, we meet every 6 months to discuss projects. I won't be giving away any technical details of which I've signed a non-disclosure agreement, but it's to create a travel adapter for the human body. Just like you have an adapter in a socket on a wall, this project has taken that motif and talked about a travel adapter for the human body. And the way it works is that there is a hub device on the arm that is tethered to a smartphone, and it's supposed to help your sleep patterns as you undergo what's called jet lag or shift lag. And it's also about overcoming traveler's diarrhea. It's about the prevention or early onset and overcoming traveler's diarrhea by looking at the human body and releasing different biochemicals into the body through this device that's implantable. It looks something like this. This is all in the public domain. This is an artistic illustration. A user with an entrained implant and its accompanying external hub works in the field. The user inputs a desired time shift, so they're moving from this phase to this phase, and the body starts to respond based on what's happening and being emitted in the cellular production of therapy in the human body. So you can overcome the sleep deprivation as you move from one place to another, or you undergo shift lag, as in shift work. And this implant works with the body's physiology. Now, I want you to think where you would come in as software developers in this process. This is really about biology. This is really about engineering. But you've got a software development degree. How would you go towards being a part of this in the future? This is the device close up. As you can see, the internal cellular factories that are emitting therapies to the individual as they prompt the device to emit these internal cellular factories and therapies. They're peptide therapies, to be precise. And so I want you to start thinking about not only is it human systems integration, but we're also adding what's called cell-based therapy into this. And you could talk about lots of moving parts in this system of systems and maintaining some kind of equilibrium in the whole complexity. So, you've seen this, I know, many times, but here's a generic example of a systems development life cycle. There are many different types of methods out there, but just think about this. You empathize, you define, you have a proof of concept where you've ideated. Tonight we'll be hearing about your ideas and your prototypes, and then you pilot and test. But when we're moving towards human trials or implantables, we're moving away from the pig trials or the mice trials, and we're going towards human trials. This is where you've got to consult the end user. You cannot build software without bringing the user close to you as a developer, asking those important questions like what are the values that you want to see espoused in the software that you develop. And so think about user interfaces, which is really your niche, human to device interaction, kill switches that are both physical and soft, device information that moves from hub to smartphone, the operational scenarios like in-body, on-body, and external, and how this information flows between these different components. What are the things that you need? Speech commands to the hub device or to the smartphone, touchscreen, key inputs. You need to map this out. And really, engineers in systems engineering are not the best people to ask about these systems flows. I actually think software developers are the best people, and software engineers are the best people to ask for what's coming in that kind of end-to-end diagram. Now, 2 more slides to go. We define primary human actions, which are the direct interface to the software or to the components in the system, and then secondary human actions. And these secondary human actions are often forgone: quality control and training. So what is the role of the human in actuation? Sometimes people talk about implants in this scenario. Others talk about ingesting a device and swallowing it. But what are the human actions that will actually take place? And how does software development aid in this process if this actually is deployed to all US warfighters? So the principal learnings of today's talk, it's only been a 5-minute talk, I've held to time. Has anyone consulted the US warfighters? The answer is yes, but not enough in my eyes. DARPA and DOD might think this is the coolest idea on planet Earth, and so might you, with the benefits that possibly outweigh the costs, but how do we prove this? What do other stakeholders share, and do they share the same sentiment as the US warfighters or the Department of Defense, and have we asked the public, for example, or even regulators? And here's a question for you, or some guidance. As software developers, when should you get involved in such a process for a complex semi-autonomous system? Is it down the end of the prototyping phase, where we sort of whack on security and whack on an interface and whack on an end-to-end monitoring and validation metrics? Or should you, as software developers, be embedded right at the outset, at the beginning of this process, and figure it out? How does data flow through from component to the external world? And what are the future systems as they continue to grow in complexity? How are you going to interface with these? So with that, I thank you for your attention. I wish you the best with your talks, and I can't wait to hear them.